Hello and welcome to another code review on a TinyGo project. This time we'll be looking at a driver for a GSM GPRS module. So I'm going to be opening up these files one by one and sort of commenting on what I observe. So first off, we have some global variables declared with errors new. This is what I would do. You can also declare your own. I think there's a way of declaring constants as errors, but it's not something I usually do. This works. This is tried and tested. This is how the standard library does it, and it just works. So good to see. We then have these methods. The connect method has some erroring here, fmt.errorf. This does allocate when it is called, so I would generally avoid these fmt calls. You can just return the send error, I guess, and have it somehow encode this information. You don't really need to wrap errors in drivers unless well, there's different ways of calling send. So this really looks like it could be its own method, right? Like cget attach equals 1, wrap in your own method, and if send fails, return the flag error. Having these calls sprinkled around the code, which take in a string, can be confusing. I understand the GPS module works this way. Usually it's got a WART connection, which receives predetermined commands. I'm just thinking out loud. It would be more expressive for this to be wrapped in its own method. Like this could be just a single method that's enable multi-connection mode, and it has this call within it. And if send fails, maybe you can find a more less heap allocating way of doing errors. Yeah. This is during the connect. So this is called ideally once. So it's not so critical, since you call this method once at the start of your program. If it's going to be a static GPS, not sure how often your GPS would disconnect during normal operation. If it's disconnecting more often than not, then this will be a problem, because if you have an error during that operation, you're going to start allocating, and here you're allocating every single time connect is called, because you have an if clause. Either this statement or this statement executes. fmt sprintf allocates. Okay, there's no doubt about it. This is going to allocate at least a space equal to the size of this string, replaced with these. So proportional to the size of user and password. I'm not sure what APN is. Maybe it's okay. That's what you're calling with, usually constant length string. So this is not good. It seems to me like what you want to do here is have send be, maybe have a buffer in your device So maybe this person has put a buffer here. Yeah, so he does have a buffer, or they have a buffer. You can use FMT append F, and send can receive what would be a byte buffer instead of a string, and that would solve this issue. So what I mean is, I'm gonna have to, open up a brand new project. Yes, I trust authors. So text file. So d dots. Let's maybe your send could receive a byte, right? This is what I'm mentioning. It returns an error, and then when you call send, before you call send, you do fmt.append f, right? And here you pass in the buffer, message fmt buffer, cgat, right, equals %s, and data. And this will not allocate, but it is extremely slow because you are using reflect here. So what I usually do is I avoid fmt append f and just straight up use the append methods, the append functions in the strconv package. So message, so you start appending, message equals append d.buff, and let's make this more correct. You start appending cgat is equal to blah blah blah. You can append a string this way. This is valid go. And then we continue with the message. Message has already been declared. And just straight up append the rest of data right here. And this has the same effect as appendf, right? And if you're appending a number, you use the strconv package. There's append functions. Append float or append int. They work the same way as this append function, except that they take in a number and append the textual representation of that data. So look for the strconv append functions to avoid reflect, because FMT makes heavy use of reflect, and you don't want that if you want your code to run fast and lightweight, all that good stuff. It's nice this person's using the slog package to log. That's really cool to see. I'd err on the side of not using the info warn error methods on this, and define my own methods which use the log attrs. So what I mean is, if maybe we go in here and go in the, so this is what I like to do. I like to find my functions that take in slog attributes, and this will not allocate as long as your attrs is less than 5 or 5 in length and less. So this is, I feel like this is a good pattern. I've used it for many projects. It's guaranteed to not allocate on small targets. Really nice what you got here. I defined this logger type because I didn't want to have to define these methods on every single type in this package which can log. I just embed logger and boom, you're done with it. Like Khan has these debugging methods after you do that. And it's really comfortable, nice to work with. Let's see an example of it in action. Like here's a trace call, which takes in the message of the log and a lot of attributes, string type attribute, UN64 attribute, and yeah, doesn't allocate, works like a charm. Next up, we have this callback function, send with options, func buffer byte. Okay, I guess this callback is processing the response. Not sure what to make out of this, because it does say send, and we haven't been dealing with responses here. I don't think we have. Okay, send with options, default response check. Okay, so sometimes you want to do a special response check. Okay, it's just like, okay, you do deal with responses every single time you interact with this device. Here you do need a special condition, I guess. Byte contains. This looks pretty good stuff right here. I just put this on its own line. You're not doing yourself any favors by having this whole statement be in front of the if condition. You usually do this when it's a short and sweet statement that you can have on the same line. Here, just do without this whole prelude to the actual Boolean condition of the if statement. Yeah, that's my just my suggestion. Take it with a grain of salt. This is up to taste, I'd say, but if you're doing this, no, I'd be inclined to ask what exactly are you gaining. But let's continue. This is looking really good, this part. Like, this is, no allocations here. Bam. Close connection. Okay, so you're connected here, and here you close the connection with state. This is nice. I often see this. I would not put this in front of a... You don't want to export this. You almost never want to export state which affects the control flow of your program, of your driver, like this. This should be behind a method that returns the state, so your users can't accidentally change the state by assigning to it, but they can call it to check what the state is. This is how I deal with. I do the same thing in this here. Bam. There's a state method, returns a state, but you can't access that state. You prevent users from accessing that state because that state can only be changed by operations with the API. Like open will, under the hood, change the state, but the user is not supposed to do that. They're supposed to use the API to change the state, not just assign to it. Same thing here. I've been talking about. This could be just append it to the buffer and then send the bytes via same what we've been talking about. Connection send. So this is likely code that's going to be running on every inside the loop. This is going to be, you're going to call this over and over again. I do suppose it even has a loop inside here, but this is what my intuition is telling me. This is going to be called I mean, if you're sending data through a connection, where else could you be sending that? Sim 800 init hard reset. Oh my goodness. Okay, never mind. I mean, this for sure is going to be called within, because this is like the lowest level send message, and you are allocating right here. Oh dear. So you've taken a string in, and then you've converted it to bytes by using this function. So this makes a copy of the entire CMD string, and just makes a copy of it and adds these 2 characters behind it. So even if you could send us oh yeah, this is not great. You really want to work with a byte buffer. I mean, how would you even? I mean, you definitely do what I've been looking at right here. Working with So I guess writing this driver is not easy, because you do need to like terminate your message every single time. So you can either put this RN here, like in all your raw calls, like here, /r/n, or you can do it inside the send method. Now, you do inside the send method, you gotta make sure that buffer you're receiving has the capacity. So you can make use of the capacity field in your byte buffer, because we're talking about changing this, right? We recall that we're talking about changing this signature to be a byte slice. So what you can do in send is, if so the free amount of space in your buffer is cap b minus len b. If free is less than 2, oh, we got a problem. Return IO short buffer, I think. You can do that, use a pre-existing error, or, make your own. Obviously, you can declare this as a global variable to avoid heap allocations. Too long message for our internal buffer, because B, you surely use B as your internal buffer. I mean, you want to use B as your always want to pass in your internal buffer in here, unless the user wants to somehow has access to the send method, which if you can avoid it. If not, do this, and that the capacity is the capacity of your buffer. And here, now we do append b, and I think this could be a nice solution to the problem you're having here, in which you are allocating every time send is called. That's going to create a lot of garbage, and it might not crash today, might not crash tomorrow, but I mean, TinyGo's garbage collector isn't watertight, so you wouldn't write this code and see. We're writing TinyGo so we can write this code and get our project working as soon as possible. That's a good reason to use TinyGo. But as soon as you get that project running, you might want to start backtracking and looking at these issues and start saying, hey, maybe I can avoid this heap allocation. And if you want to write a driver that's used by lots of people, that people don't use your driver, have it run for 30 days, have it crash, and they're scratching their heads like, oh wow, this driver is crashing every single time after 20, 30 days, and they get frustrated and maybe like they just go, okay, I'm just gonna use C, because C doesn't have this problem, because C doesn't give you these luxuries, and people might be misguided and think, oh yeah, well this is a problem with TinyGo. No, it's a problem with how you program TinyGo. You can do awesome stuff in TinyGo, but eventually if you heap allocate and you don't have a really good garbage collector, if you're not using BOEM garbage collector, I think maybe this is solved by using BOEM garbage collector. Not sure. It's a new garbage collector in TinyGo. TinyGo BOEM garbage collector. Maybe this. Reconsider a compacting. BOEM. Here it is. So Ike wrote a blog post about this. I'm not sure if this actually talks about the implementation. For example, the BOEM. Okay, this was maybe written before he implemented it. 2020, yeah, for sure. The BOEM is very new. And this, oh, look, May 2024. So this is from now. So yeah. I feel like it's very easy to avoid this using what I've just shown. So avoid it if at all possible. We then have read response. Yep, using that buffer, check func. Nice. Parse error message. Clear buffer. Okay, so this is another. You're allocating here because you're converting it from a byte buffer to a string. I really hope you're not using this every single time. Doesn't look like you're using it at all. So okay, might not be a problem, but do keep in mind whenever you do this pattern allocates, makes a whole copy of data onto the heap every single time. Yep, not great. So this is maybe one of those situations where you might want to define an error type. Error message, right? Maybe you want it to be an internal type. I'd make it internal probably. Struct. So, this would have the message string, something constant that, you know, and then it had like the data that you wanna from the response. And so what you could do here, and your type device, if you don't want to allocate at all, if you want this to run forever, you could have an error message here, in here. Internal error. So your device has an this sort of type. It's got contained inside. So extract the part after the colon. So I'm not exactly sure what's happening here. It looks like he's always returning a string, but say you're, let's imagine your error is after the colon. So you look for that colon. If IDX is less than 0, we didn't find it, so just return nil. Now, if you did find it, your RX message, you received a message that is and this is bytes, right? Bytes, index byte. And you can straight up just use this. This is going to be faster than searching for a string. Index byte, right? You're just searching a single byte, so just do that. If IDX is less than 0, return nil. If you do find the colon, oh, there's an error in here. So data IDX. And it's everything after the colon. Oh, I keep trying to save it. But I don't want to save it. I just want to return d dot intern. So now we d dot internal error is equal to error message, bam, message, and maybe here you can also include like the message, customized message, like, oh, so I'm parsing the error message after trying to what was it, like set up multi-mode after basic AT check. So so maybe a message says basic AT checked failed, and here we do the data equals rx message. According to the data sheet, the message is after the colon, so bam. And then we return the pointer to this. And d dot internal error. And maybe you just print out the message if you don't want to allocate on error. Maybe you format it pretty. In any case, this will not allocate until error is called. And sometimes your user just cares that there was an error. They don't need to call the error method. So you've not allocated here. The one issue with this is that the user can't store the reference to this error to print it out later. Because if there's another error, you're going to write over the error. So there's limitations to using this. But that's just, that's just life. You gotta choose your trade-offs, right? You either allocate, so this new error, and this is just like, bam. This allocates, and the user doesn't need to worry about if I store this error, its message is going to change over time because I'm getting new errors and it's overwriting my error. You can do this, but usually, no one stores errors, right? Until they do. You can document this, like say, hey, error returned is going to be valid only until the next API call of that device. You can document that. Sounds it sounds okay to me. Sounds like a sound way of using the API. If you get an error, you print it, you log it, do whatever you need to do. You don't store it. I think I've gone off on the rails a bit because I thought this is a really cool pattern. I've not used much myself, but cases maybe where you have very dynamic errors, maybe like a GPS system, which is incredibly complex and has a lot of depth, maybe you can leverage this kind of non-allocating error for those dynamic errors, which have like a little message in them, where you also have to add some context, maybe with additional strings. So yeah, I thought this was something cool I'd share. Let's continue with the code review. If we go on, Okay, here we go again. This will allocate, right? So, oh dear, why did you choose? So is this only called once? Yes, it's only called once. Okay. Okay, it's not the end of the world. I mean, this is going to allocate something the size of d.end, and then it's going to trim it. It's going to trim the space. If that's a lot of space, then you're just, you allocate a lot of stuff for nothing. Here, what you can do is, instead of the strings, the bytes package has equivalent methods to the strings package. So I'm pretty sure there's a bytes dot trim space. Every single time you're looking at like a strings method, a strings function, there's an equivalent bytes function. So I'd suggest this person do away. You can leave it like this, honestly. It's probably not allocating too much. It's an init function. You're calling it once and never again. So it's fine. But just something to keep in mind, You can avoid allocating if you use the bytes here. Thing is, this is going to be pointing to your buffer and you're going to be overwriting it. So you will want to convert it to strings somewhere along the way. So yeah, this is fine, really. Let's continue. What else do we have? Send with options. I mean, I think we've made a lot of good points, covered a lot of ground. Quite happy with with all the little details we picked up. I feel like there's a lot of content, to learn from this cool little example of a GPS system. Yeah, just consider maybe not calling string every time you receive a buffer. I mean, unless you really need to store like a constant string that will not be overridden in future calls. I'm not that familiar with this driver. You're calling it inside of here, inside of connect. And what are you doing? You're literally only using it once. So maybe this parse value could return a byte slice so that it's clear that, hey, this is a slice. And I'm going to change it in the future. Use it. If you want, convert it to a string. You can convert a string over here. But parse value within, all it does is call bytes index instead of, oh dear. And this, oh, so find the key in the buffer. It does seem like there's more than one problem here, because this also allocates. So a lot of allocations going on here. This can very likely be improved by finding a better way around. I mean, reading the datasheet and maybe getting some more insight as to where is the key. Is maybe the key is always at the front. Maybe you don't need to worry about parse, like finding the key. This does look like I don't think I've ever seen a driver which makes you find a key, or like any API which makes you find a key within a response. So yeah, maybe there's probably a much better way around this. This all looks very iffy to me right here. But let's move on. Yeah, I think we can end right here. I think the lessons learned are string allocates, when you convert a byte slice to a string, that it's going to allocate every single time. You like it or not, it's going to allocate. And you can avoid that by always staying in the bytes domain, so never converting the string until you really need to store some data value inside of your device struct. For example, that init function had that exact case where I'm thinking, hey, this does make sense. You do want to convert this to string because you want to hold a reference to that data, which you then use in the future. It's also within an init function. Makes a lot of sense. But the rest of the time, hey, I'm getting this value. I'm just getting this value, and I'm going to check if it's equal to this, right? That's a clear-cut case of where you want this to probably return a byte slice, and then here do bytes.equal. Hey, is this 1? And yeah, stay away from those allocations. That's all I got for you. See ya.